technical interview question is known as the needle in a haystack problem. Given a list of items, find the number of items that are present in a second list. So some concrete examples. Suppose you have a list of 10 million emails or security codes or employee IDs, whatever. And you have a list of 1,000 items that you want to find in the first list. How would you do that? Now you're a professional Python programmer, so you know you can use the in operator to check if an item is in a list. So initialize some numbers. You say this is the needles in a haystack problem, so initialize. So you want to say initialize something like fun1 equals to 0, and then you say for and in needles. So you're iterating through needles, if and in haystack. So you're saying that if 1 is in the haystack and then if 3 is in the haystack, then you increment that by 1. You could either say plus equals to 1. Now that is a perfectly valid solution, but it's not the most efficient solution. The reason for that is that the in operator is O of n in the worst case. So if you have a list of 10 million items and you're searching for 1,000 items, then you're going to have to take the 10 million multiplied by 1,000. You have to make this 10 billion comparison. If you were to multiply them, take 10 million, multiply that by 1,000, it gives you somewhere close to like 10 billion comparisons. That's very expensive. In more recent versions of Python, there has been so much optimization for membership checking that it's not as bad as it used to be. But it's still not as efficient as it could be. And if this comes out as a technical interview question, you're going to want to be able to solve it in the most efficient way possible. So let's talk about the set data structure. This is how a set looks like, right? You take a set and you wrap that with, you could do something like this and it becomes a set of 1, 3. You could also just use this notation and do it like that, it still works. And a set is a data structure that is similar to a list, but it's unordered and it doesn't allow duplicate, so there's no duplicates in this. If you try to do something like 1, 3 and then put 1 in here, you see that you remove the 1 and now you only have 1, 3, right? So this is perfect for the needle in a haystack problem. So if you're given two sets, you can use the intersection method to find the items that are in both sets. I'll give you an example. If I say A and I put something like 3, 4, 5, and then I have B, I'm going to have this as 4, 5, 6. Now these are two sets. You can use the infix operator and. That's also valid, so you could do something like A and B, or you could do A or B, and that's a much better solution. Let's implement these examples and compare the running time. If you watched the earlier videos about how I recommend you not to use Python lists everywhere, if you could use the vectorization pattern to solve problems, you should watch that video. This video kind of borrowed the same timeIt function, a utility declaration function, so I could now add my timeIt onto my different functions. timeIt, and I'm going to do the same thing here. I'm going to say timeIt. Now the first one is what I showed you. I said first initialize found and then iterate through the needles, and then if you can't find them in haystack, if you do find them, found plus 1, and then if not, just continue on until you find it, right? So potentially this could end up comparing 10 billion comparisons if you have 100 million multiplied by 1,000, all right? Let's put some concrete numbers and try to compare them, right? So let's initialize the numbers. I'm going to have 10 million to begin with. So 10n equals to 10 million. I want to maybe just randomize the numbers a little bit. So I want to import random. And I'm going to just maybe set a seed number. This could just be the same, it doesn't matter. Just so that for reproducibility. And I want to create my haystack now. Okay. My haystack is just going to be kind of like, you know how we talked about a set there? So I want to have my set, and then here I'm just going to say sample from some numbers. So I don't want to have 10 million, 1 to 10 million because that's not fun. I want to say something like take 1 to let's say 20 million and then sample 10 million out of 20 million. So I want to say sample out of 20 million, take only 10 million, right? So what this is going to do is going to find, actually you will need to put them in the range. So it says that, okay, 20 million, this is a range of 0 to 20 million, so 0 to 19,999,999, and then sample 10 million of that, alright? Then I want to have my hay, so I could just have I, and this could just be a very simple sample. Actually, might as well just copy the same thing. It could be the same idea, right? So just take this one, but instead of sampling 10 million, I just want to randomly get 1,000 numbers. Okay, let's take a look and see what is required here. It takes haystack and needle, so we need to pass in both of that. We said haystack, and then we said I. Okay, I want to print stuff out. So if you look at the decorator, it returns what? It returns, first of all, it returns the time. So it returns a tuple of two elements. The first one is the time, the end time minus the start time, and then the second is the result. Where does the result come from? It says result is when you call the function with the arguments. So the function is gonna be this, it return the found. So this is my result, this is my time, and this is a tuple of 2, result and time. So I could say something like, take the time, that's the first, and then return. And I just do the tuple unpacking. Okay? I'm gonna do the same thing now for find2, and I'm also gonna say time 2. This is also because of the same idea. We said this is the first element of the tuple, that's gonna be the time, then the result. So time, and then the result, we're just doing tuple unpacking. Okay, let's go ahead and just say how many items did they find anyway. So let's go ahead and say find, or actually let's say find1, found, then we want to say R1 items. Then I want to go to the next line, so just a new line. I want to say find2, found R2 items. Okay, save all of that. Let's say Python, print our working directory, change the directory to a desktop because that's where we are at. Then I want to say Python hey.py. Okay, so you see an issue here. It says that the length of haystack and needles, this doesn't work because there is an unsupported operand types. So this works because it's assumed that both of them are a set. So you could either go ahead and do something like if say is instance, if the needles is not set, then you can go ahead and just convert that to a set of needles. Alright, this is one way you could do it. But another way you could do it is to ditch this syntax. So this is the infix operator, right? You require that both of the operand be set. But if you don't want that, you could also change this and just have it this way, intersection. This is the same result, but this will work as well. Can just be an iterable. It doesn't have to be a set anymore. These needles could be a list. In this case here, it is a list. We haven't converted that to a set, so this will also work, right? So let's just save that. Let's clear the screen here and let's run it. So out of it found 46 items. The first method, find1, found 46 items. The find2 also found 46 items. So you know that they work equivalently. So this is the same as this, right? They give you the same results. Now the first one, just go through the for loop, if this, and then found this, and then just return found, increment the found, and then return found. This is basically using the set method, okay? And they work equivalently. But which one is faster? So this is where we can print the time and compare the time. So let's say print. You could have a multi-line print so that you don't have to keep on doing the new line stuff here, which would be quite ugly. Okay, say find1 takes how much time? This is time 1, sex, and then find2. You do the same thing. You say find2 is how many times faster, right? So let's run off that, let's save that. Get back in here, let's run that. And there you go. Notice that this is still very fast, right? This is 0.00018. The reason you see a little bit of delay is actually has to do with this. It has to construct the haystack and the eye. This is what's taking time. The actual find operation is still really, really, really fast. But if you compare both of them, you can see that there's a difference here. It's about 3.5 times as fast. It used to be much worse in the earlier version, something like 9,000 times slower on Python 3.4, 3.5. But with the optimizations that have been made, on my current machine I have Python 3.10 and 3.11. On my current machine it's only 3.5 times, maybe sometimes 4 times slower. Algorithmically, it's still a superior solution and one that you should be able to implement in an interview. So finding needles in a haystack is quite a common problem. If you're writing any amount of code that deals with data, I hope this is helpful to you. I'll see you in the next video.